So if I woke up tomorrow and wanted to land a six-figure cloud engineering role in 2026, I would not do what I did years ago. The industry has fundamentally shifted. Back then, theoretically, you could get hired just by knowing how to spin up a virtual machine and set up a VPC. But today, that's actually the bare minimum, as the bar has been set higher. So if you're still following roadmaps from 2 years ago or so, you're already behind. In this video, I'm giving you the exact week-by-week blueprint to get you from zero to hireable on Google Cloud using the exact same stack I used for my own portfolio and the stack I used to build my platform Maqtba.com. So we're talking AI pipelines, serverless, and high-level FinOps. So if you're tired of being ignored by recruiters, put these certifications down for a second and let's talk about how you can actually build. Now, phase 1 isn't about the cloud at all. It's about the tools that make the cloud possible. So if I wanted to start over, I'd spend my first 7 days learning the engineer's hammer. So on the first week, I'm not even opening the GCP console yet. This is because the biggest mistake most people make is learning the cloud before they even learn the terminal. In 2026, if you're a cloud engineer, you're not just clicking around, you're an automation specialist. So I would spend 48 hours straight in the Linux terminal. I would learn the grep, the awk, the set, and any other necessary command. And of course, I would learn basic bash scripting, because when your cloud run container fails, you're not gonna be clicking buttons in a user interface, but you're going to be reading logs in a terminal. Next, I am mastering Docker. So today, the unit of the cloud is containers. So if you cannot containerize a simple Python app, you're basically useless to a DevOps team. So I would learn how to write a multi-stage Docker file to keep my images slim. Basically, a slim image means faster cold starts on Cloud Run. If your image is 1 gigabyte, your app is slow. And if it's 50 megabytes, using a distroless image, your app is lightning fast. Of course, this is the difference between a junior and a senior. So do not just learn the commands. Build an app, containerize it, and run it locally. If it works on your machine, then we're ready to move it to Google's hardware. And now that we have our container, we need somewhere to put it. So we're not going with the old way of renting a server, we're going serverless. Now in week 2 and 3 is when we enter the Google Cloud ecosystem. So if I were starting over today, personally, I wouldn't begin with compute engine. Virtual machines are the lowest abstraction layer of the cloud, and for most modern web workloads, they are unnecessary overhead. In 2026, Cloud Run is king for application compute. This is due to its scaling to zero policy. So if no one is hitting your service, the compute scales down to zero. So basically, you pay nothing for idle capacity. Also, Cloud Run supports up to 1,000 concurrent requests per instance. So with the right architecture, a single container can handle serious traffic. Also, with Cloud Run, you don't manage virtual machines, you don't patch operating systems, you don't think about the cluster scaling, you just focus on the code and the container. Now, when deploying, notice the authentication section. So juniors select allow unauthenticated because it's easy, but seniors choose to wire up IAM properly. So if I were starting over, I would spend an entire week just on IAM. Understanding least privilege, service accounts, and identity boundaries is what keeps you from being the person who leaks a million customer records. Now, most people think that Cloud Run is just for web apps. Well, it's not. It's for background tasks, cron jobs, and most importantly, in 2026, it's for AI inference, and we'll cover that in phase 4. So, your goal for the first month is to have a live containerized API running on Cloud Run, map it to a custom domain, secured with an SSL certificate, and restricted by IAM roles. Now, compute is only half the system. Your apps needs to think and it needs to remember, and this is where data comes in. So welcome to week 4 and 5. Now, this is where cloud engineers begin to stand out. Now, if I were to start over again, I would treat SQL as a core infrastructure skill, not just something for analysts. In 2026, BigQuery isn't simply a reporting database, it's the analytics backbone for Google Cloud. Billing exports, audit logs, VPC flow logs, application events, all of it can be streamed into BigQuery and analyzed at scale. Now, that's real operational power, and BigQuery achieves this performance by separating compute from storage. So your data is stored in Colossus while queries are executed using Dremel's distribution compute engine. Now, why does that matter? Because you can store massive data sets at low cost and only pay for compute when you actually run a query. For example, take a look at the execution details. We're just scanning a very small amount of billing data. If this table wasn't partitioned on usage start time, the query would scan the entire billing history. Now, that's the difference between a negligible cost and an expensive mistake. So you need to master window functions like row number, rank, and qualify, as we use these concepts to build our billing auditor. So if you can walk into an interview and demonstrate that you can analyze and optimize cloud spend using SQL, you're no longer just managing infrastructure. You're driving financial efficiency, and that's FinOps thinking. But analyzing data is only part of the story. Today, cloud engineers are expected to make data actionable and intelligent, and that brings us to phase 4. So in phase 4, I would focus on building event-driven AI pipelines, and here's the exact stack that I would use. We've got Cloud Storage, Event Arc, Cloud Run, and Vertex AI. Now let's walk through a real scenario. Imagine a customer who uploads a 50-page PDF invoice into a cloud storage bucket. Now, that upload triggers an Event Arc event. Event Arc routes the event to a Cloud Run service. Of course, this is the same serverless container platform that we have discussed earlier. The container processes the file and sends it to Gemini through Vertex AI SDK. And then Gemini extracts structured information like total cost, vendor name, and invoice date. The container then writes the structured data into BigQuery. So the invoice is no longer just a PDF, it's searchable, queryable data that can power dashboards, alerts, and audits. Now, why this gets you hired? Because recruiters will not simply ask you if you know Linux. Well, they will ask you if you can integrate AI into their production workflows. So when you build a pipeline like this, you demonstrate event-driven architecture, object storage, and integration, serverless compute design, manage Gen AI implementation, and analytical data persistence. So you're not experimenting with AI, you're operationalizing it into a scalable, production-ready system built entirely on managed services. And in a real environment, this entire pipeline would be provisioned using infrastructure as code like Terraform, not manually, to ensure reproducibility and compliance. So this is the kind of systems thinking expected from modern cloud architects, but none of this would matter if no one knows you can do it. So you need a system to prove your value. So now we're in phase 5 and this is the final month. This is where we turn everything we've discussed into proof. So as you've seen, the first month is about foundation. We talked about the terminal, Docker, Cloud Run, and IAM. So you learn how applications run, how containers work, and how identity controls access. The second month is about data. We've got BigQuery, SQL, cost awareness, and partitioning. So your systems here don't just run anymore, they generate insight. And by the third month, you're connecting everything. We've got Vertex AI, Event Arc, and Terraform. Now, here's the point that most people miss. Do not just post code. Post the system design diagram, use Excalibur or Lucid Chart, show the data flow, show which service account calls which API, show why you choose Cloud Run over Google Kubernetes Engine, explain why you partitioned your BigQuery tables, and explain your architectural trade-offs. Hiring managers don't just look for syntax, they look for thinking. Cloud engineering isn't about being a genius, it's about consistency. Too many people get stuck in tutorial mode, watching videos, copying commands, but never really assembling the full system end to end. So stop consuming and start building. Head over to my platform Maqtba.com and choose the course that fits your level and start building. Now that's it for today's video. I hope everything was clear. If you've got any questions, drop them in the comments below. Don't forget to hit that like and subscribe buttons, and I'll see you in the next one.